Welcome to the world of extreme machines. Those giants who lay claim to being the biggest, longest, heaviest, and most powerful on Earth. Supersized monsters that can literally move mountains.
When I say it's beyond imagination, it is beyond imagination.
Big brutes that boggle the mind.
The typical reaction is, oh my gosh, I never knew how big it was.
Miracle machines that can take your breath away.
When we say it's the biggest big screen on the planet, there's just nothing like it anywhere in the world.
Giants that can do the impossible.
We could suck all the air out of Madison Square Garden in about 2 minutes.
These are machines like no other. These are the world's biggest machines. And many of them are built to fly. Ever since the Wright brothers took flight in the first successful airplane in 1903, we've been on a never-ending quest to thrust more payload into the sky. From Howard Hughes' Spruce Goose flying boat to the ever-dependable B-52 bomber, up to today's airline workhorse, the Boeing 747. We've been driven to build them big. And no one more so than the Russians. The Antonov 225 is the world's largest airplane. Its dimensions are staggering. It's nearly a football field in length from nose to tail, and its wingspan stretches an amazing 291 feet. Built originally by the Soviets in 1988 to transport their prototype space shuttle, it's used today as a super cargo carrier, capable of carrying twice the payload of a Boeing 747.
Any of the numbers you use to describe the AN-225 come under the heading of superlatives. For instance, it was the first aircraft to fly that took off at a gross weight of greater than 1 million pounds.
Everything about this jumbo jet is massive. It's powered by 6 giant turbofan jets, each capable of pumping out 51,590 pounds of thrust. The Soviets had to incorporate many innovations into its design because of its size, including a 32-wheel steerable landing gear.
In addition to the nose wheel section being maneuverable, the rear parts of the main landing gear are also steerable. The main landing gear consists of, on each side, 7 units of twin wheel assemblies. The last 4 on each side are steerable. And having the last 4 trucks, as we call them, of the main landing gear assembly steerable on the aircraft makes it able to be turned in a relatively small turning radius so that you don't have to build massively large taxiways and parking aprons for this very large aircraft.
The Giant also sports a wide split tail, designed to avoid the air turbulence created by large piggyback loads, like the space shuttle.
If you have a single-tail aircraft, there's some turbulence that is set up by the airflow around your cargo that you're carrying on the back of the aircraft by making a double tail where the 2 tail sections are outboard, then the turbulent airflow goes between them. Then that allows for a smooth aerodynamic flow over the vertical fin and rudder assemblies on either side of the horizontal stabilizer.
The AN-225 made its international debut in a style befitting its dimensions when it landed at the 1989 Paris Air Show with a Soviet space shuttle on its back. From the beginning, it caused a sensation. However, its glory days were short-lived. After the fall of the Soviet Union in 1991, the plane was without a mission. It was grounded in Kiev and scavenged for parts. Then, after nearly 6 years, the only AN-225 ever built was rescued from the scrap heap by the Antonov Group. who put $20 million into refurbishing it as a cargo carrier. Today, their investment is paying off. Carrying everything from heavy construction machinery to oil drilling equipment to fleets of cars, the future once again looks bright for this giant of the skies. Crucial to the success of the Antonov and other big, powerful planes was the development of the jet engine. Today, the engines are becoming giants themselves. Dr. Hans von Ohain of Germany and Sir Frank Whittle of Great Britain are recognized as co-inventors of the jet engine. Ironically, they researched separately from each other during the 1930s and knew nothing of each other's concepts. Yet both produced functional jet planes by the early 1940s. Jet engines operate by sucking in air with a fan. They then compress the air inside the engine and spray it with fuel, which is ignited. The burning gas expands and blasts out the back of the engine, thrusting the aircraft forward. General Electric has produced the world's largest and most powerful jet engine, the GE90-115B.
We've broken the world's record twice for demonstrated thrust, most recently demonstrating 127,900 pounds of thrust. That's equivalent to over 100,000 horsepower.
The massive engine was developed to power twin-engine airliners like the new Boeing 777. Many experts believe twin-engine aircraft may prove to be the wave of the future in the airline business, because they're less expensive to operate than four-engine planes. Even veterans of the aviation business are amazed by the engine's size.
They're pretty much awestruck. A lot of them really just are kind of silent and just, big eyes, and this look on their face is just almost incredible to see. It's so much larger than any other engine they've ever seen before.
The key to the success of the engine is its giant 128-inch diameter fan, one of the largest ever constructed for a jet engine. The fan sucks in enormous amounts of air that allow the engine to generate its record-breaking thrust. Most jet engine fan blades are made of extremely strong titanium. However, constructing a fan this large, entirely of titanium, would have made the engine impossibly heavy. General Electric solved this problem by designing new fan blades made of lighter carbon fiber polymeric materials, and then giving them a titanium leading edge for strength. The shape of the fan blades is also a key ingredient in creating the engine's enormous power. Older engines used simple straight up and down fan blades, but the GE90 is equipped with aerodynamic swept wing blades.
The unique shape of the fan blade is key to the technology of the engine as well, and that 3D shape, that beautiful 3D shape that you see, draws in more air than just a straight up and down or radial blade. It actually draws in more air in the same circumference, and that extra air gives it that extra little bit of thrust that we need.
Before the engine could be certified for flight, it had to be put through a battery of demanding tests.
The testing is to assure that the engine can fly in any environment safely. We look at any extreme environments and make the testing more severe than what you'll see in operation on an aircraft. We have water ingestion testing. We take in about 4.5 tons of water a minute and show that the engine can continue to operate and not stall, taking in that kind of volume of water. We also do hail ingestion testing. We have several little cannons that shoot hail into the engine. They shoot about 3/4 of a ton of hail in 30 seconds.
Nothing was left to chance. Technicians tried to recreate and analyze every possible problem that could happen to the engine.
An engine, when it's operating on an aircraft, takes in a lot of air. It can also take in anything else in the environment, such as a bird. So we're required per the FAA to shoot bird carcasses into the engine and to show that we can continue to sustain operation even after taking in the bird carcasses.
Perhaps the most important test of the engine is the flight test. Since the early days of aviation, Special planes have been designated for testing new equipment.
GE actually owns a flying test bed, a 747 aircraft, where we test engines prior to doing flight tests on any new aircraft. In the case of the GE9115B, we had this huge GE90 engine on the aircraft with 3 smaller engines.
Amazingly, the engine proved powerful enough to fly a giant 747 by itself.
We had these 3 smaller engines that we actually cut the power to all those engines and just flew it on the one GE9115B engine. Another story about the flying test bed that's pretty amazing is the air that's pulled through the engine to generate the thrust. As it was exiting the engine, it was actually moving 400-pound rocks that were kind of rolling behind the engine. I don't think anybody expected to see that.
After 2 years in development, the $21 million engine is now a fixture on the Boeing 777, ushering in a new era for twin-engine airliners. Fixed-wing aircraft builders aren't the only ones who think big. The Sikorsky CH-53E Super Stallion is the largest helicopter in the Western world.
It's the largest helicopter that we own. The dimensions of the helicopter, it's 99 feet long. The rotor head is 79 feet in diameter. From the ground to the top of the tallest tailblade is going to be about 28 feet.
Ever since the 1950s, helicopters have been used to carry heavy objects slung beneath their fuselages on cables. Today, when it comes to heavy lifting on the battlefield, the CH-53E is the first choice of the United States Marines.
The CH-53 Echo was originally designed to carry 32,000 pounds at 100 knots indicated airspeed for 100 nautical miles, hover on station for 5 minutes, and then make the return flight home.
The technological wonder of the giant copter is its 79-foot diameter rotor assembly.
Most normal helicopters in the inventory today carry 4 or 5 main rotor blades. Ours carries 7, which helps provide that additional lift due to our size and capabilities.
The tail rotor is also of Goliath proportions.
Here, we're looking at the tail rotor of the CH-53 Echo. You can see it's extremely large, over 20 foot in diameter, and has 4 blades. It's larger than the main rotor head of most helicopters today.
The helicopter is capable of lifting heavy objects like these 2 Humvees with ease. The total combined weight of the 2 vehicles is over 12,000 pounds. During the maneuver, the copter's rotor blades subject the Marines on the ground to hurricane-force winds.
And what we'll do today is we'll approach the Humvees and hover over them, while our crew chiefs in the back help align the pilots over the load. We'll have a helicopter support team, approximately 6 Marines underneath our helicopter, and they'll hook up the external load to the helicopter. Once we pick the Humvees up off the ground, our crew chiefs will make sure the load is steady and is riding in the correct fashion, and they'll clear the pilots for forward flight.
This giant may be the Marines' heavy lifter, but in the long history of brute strength on rails, it's muscle machines like Union Pacific's 4000 series of steam locomotives and today's AC 6000 diesels that get the job done. In June of 2004, the Antonov 225 set a new commercial payload record by carrying 247 metric tons of construction equipment from Prague, Czech Republic to Tashkent, Uzbekistan. More of the world's biggest machines will return on Modern Marvels. We now return to more of the world's biggest machines on Modern Marvels. Today's giant locomotives are the latest muscle machines to power the railroad industry. When British engineer Richard Trevithick built the first practical steam locomotive in 1804, he started the industry on a fast track to building them bigger and bigger.